Hi, this is Raghu. My topic is real-time data acquisition. Before going to real-time data acquisition, what is meant by data acquisition? Data acquisition is process of sampling signals that measure real-world and physical conditions and converting the result samples into digital numeric values that can be manipulated by a computer. Data acquisition systems abbreviated by a enormous DAS or DQ and typically convert analog forms into digital values for processing. The components of data acquisition system includes in next slide, and these are sensors and signal conditioning circuitry and analog to digital converters. And these are the three components of data acquisition system. And sensors are used to convert physical parameters to electrical signals, and signal conditioning circuitry to convert sensor signals into a form that can be converted to digital values, and analog to digital converters used conditioned sensor signals to a digital values. And data acquisition applications are usually controlled by a data acquisition applications are usually controlled by a software programs developed using various general purpose programming languages such as assembly, C, C++, Java, LabVIEW, and Pascal. Standalone data acquisition systems are often called as data laggards. Next, real-time data acquisition. These are the here we give properties of real-time data acquisition. Design real-time data acquisition and control applications with graphical development. Download to a dedicated target for increased reliability. Design with built-in tools for PID, fuzzy and advanced control. And executing on real-time operating system for a deterministic performance. Deploy as a distributed and standalone or embedded control system. And next, why we choose real-time data acquisition. Extended LabVIEW graphical programming, standalone embedded systems, and take advantage of real-time OS for precise timing and high reliability. Use wide variety of IP and real-time hardwares. And next, what are real-time VIs in LabVIEW? A real-time system means computer-based system where one or more applications must be able to synchronize with a physical process. Real-time means that computer system is monitoring the states of a physical process and must respond to charges of one or more the states within maximum time. A real-time system can then be used monitoring different parameters in physical process of presentation, warnings and alarm situations, and for control. Real-time system will vary often an embedded system when embedded system doesn't need a real-time system. Important features in such real-time systems are synchronization, semaphores, deadlock, multithreading, and scheduling. First of all, we know synchronization. What is meant by synchronization? When several applications of real-time system must together with the physical process, so the real-time system must be able to manage simultaneously. The solution is often to run several applications on computer systems or on different computers in a distributed system. These solutions require some sort of synchronization between applications and physical process. When several applications are running simultaneously on computer system, must be also some synchronization of the uses of the resources in computer system. Resources can be both hardware and software, like input-output global variables in software, the CPU, memory, disk, etc. These are some synchronization palettes in LabVIEW: notify operation, queue operation, semaphore operation, and occurrences and first call. Next, semaphores. Semaphores. What is meant by semaphore? Semaphore is simplest form of synchronization. It has two functions. These are request and release. Request means the system will move the task to wait queue of if semaphore is already occupied by another task. Release means releases a semaphore. The system will move the block tasks from wait to queue ready queue. Here the diagram shows semaphore palette in LabVIEW. Here obtain semaphore, acquire semaphore, release semaphore, and release semaphore. And here we have 5 palettes in LabVIEW. We can use semaphore VAs to synchronize 2 or more separate palettes takes so that only a task at time executes critical section of code protected by a common semaphore. In particular, use that VAs when you want to set an VAs part of block diagram to wait until another VA part of block diagram is finished with execution of critical section. Typical example could be where 2 resources want to write the same file, but only one can access to a file at a time. We can use semaphore VAs to synchronize this operation. The application could have 2 while loops in parallel. And each while loop can then write to a same file if you synchronize these operations using semaphore. And next, queue operation. What is meant by queue operation? We will use these queue operations to create a queue for communicating data between sections of block diagram or from another VI file. Here, this diagram shows LabVIEW palette in queue operations. Here we have 8 queue operations. These are obtaining queue, enqueue element, prequeue element, and get queue, release queue, lossy enqueue, enqueue element, dequeue element, flush queue. And then next, multi-threading in LabVIEW. What is meant by multi-threading and what is meant by multitasking? Here, multi-core system is a single process CPU that contains 2 or more cores, with each core housing independent multiprocessors. What is meant by multitasking? In computing, multitasking is a method by multiple tasks, as known as processors, share common processing resources such as CPU with a multitasking OS such as Windows XP, Windows Vista, etc. We can simultaneously run multiple operations, multiple applications. Multitasking refers to a ability of OS to quickly switch between each computing task to give impression that different applications are executing multiple actions simultaneously. What is meant by multi-threading? Multi-threading extends the idea of the multitasking to applications, so we can subdivide specific operations with a single applications into individual threads. Each of the threads can run in parallel. The OS divides the processing time into only among different applications, but also among each thread within the applications. In each multi-thread National Instruments LabVIEW program, an example might be divided into 4 threads: a user interface thread, a data acquisition thread, and network communication, and a logging thread. You can prioritize each of these so that operates independently. Thus, in multi-threading applications, multiple tasks can progress in parallel with other applications that are running on the system. Next slide means this gives multi-threading in LabVIEW. LabVIEW automatically divides each application into multiple execute threads, and complex tasks of thread management are transparently built in LabVIEW execution. We can also use the CPU information function in LabVIEW to find CPU about your PC. Next, what is meant by data socket? Data socket is the technology for sharing data between applications of different sources. The data socket controls provides a simple interface through which it can interface with OpQ servers such as National Instruments, Field Point from any active X container, including Visual Basic and Visual C++. You can connect to an OpQ server with a data socket using an OpQ URL, which is similar to URLs used in web server. URL
Completed.
URL provides standing mechanism for referring to locations. You already know how to use URLs to locate the things on web, and you can locate up to data items with a data socket using similar URL model. Many typical instrumentation solutions involve single location applications for acquisition and logging, analysis and presentation. However, because of rise in popularity of internet and company intranets and need to remotely monitor and control your data acquisition, you can often need exchange live data with other applications on different computers around the world. Data socket for LabVIEW simplifies live data exchange between different applications, one on computer or between computer connected through a network. If we are comfortable programming with COM, we can write programs either OpQ and custom API and automation API depending on the programming environment which we are developing our OPC client. And here the data socket palette in LabVIEW. Here we have data socket, data socket select URL. This dialog box shows for a user to select data sources and returns the URL to the data. And second one is data socket open. This opens the data connection. You can specify in URL. And data socket read. Next one, data socket dequeues and next available data value from the client's slide buffer associated with connection. You can specify in connection and returns the data. And fourth one is data socket write and writes the data to connection. You specify in connection in, and data socket close the data connection. You can specify in connection ID. And next one, this is my topic in real-time data acquisition in LabVIEW. Thank you.